This next lesson is about measuring angles. There are several important theorems and corollaries that we use to solve problems involving triangles. The first is the angle sum theorem. This simply states that the sum of the measures of the angles of a triangle is 180 degrees. That is always true no matter what kind of triangle it is. The third angle theorem simply states that if two angles of one triangle are congruent to two angles of a second triangle, then the third angles are also congruent. The exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. And I will show you on the next page what exterior angles and remote interior angles are. Corollary 4.1 says that the acute angles of a right triangle are complementary. In other words, the two angles that are not 90 degrees, when added together, equal 90 degrees. And the next corollary says that there can be, at most, one right or obtuse triangle or angle in a triangle. This makes logical sense when you consider that the sum of all three angles has to equal 180 degrees, as we learned from the angle sum theorem. Therefore, you can't have two angles that are each 90 or greater. Regarding exterior angles, an exterior angle is formed by one side of a triangle and an extension of another side. So in this diagram, I have a triangle, and when I extend one side to continue on as a ray, this angle here becomes the exterior angle. Our earlier theorem said that the measure of this exterior angle has to equal the sum of the two remote interior angles, which means that 155 will equal the sum of 115 and 40 degrees. In this picture, I have labeled for you that this out here would be angle C, would be the exterior angle. And here I would have remote angles in the two far corners. Angles X and angle C together are a linear pair. They equal 180 degrees when added together. The sum of angle X and angle A and angle B, all three of them together, also equals 180 degrees. Therefore, it stands to reason that if I subtracted X from both of these two equations, I would find that the sum of A plus B equals C.
Oops!